Okay, given the question f of x comma y is a by o of y square x and y exists in the range greater than 1 and x exists in the range 1 by y, we know that x equal to y is the straight line and y equal to 1 by x is this line. So the function lies between this, the shaded region, because it is also above 1. Substituting thus, since we know the limits, in order to calculate we equate f of x comma y integral is equal to 1. So first we evaluate the integral. So x minus 1, which is ln of x, substituting the limits, ln y minus 1 by y to infinity, and thus here we come here is 2a 1 infinity ln a by y square dy. Let us take ln y as w in order for the sake of simplicity. So y equal to e of omega y square, and similarly we write for dy e omega d omega. Thus the limits also will change correspondingly. Thus substituting the limits 0 to infinity w and integrating, we get a equal to 1 by 2. Thus since we know f of x comma y, now we are able to calculate f of y, which is the integral of f of x comma y d of x. Yes, so y 1 by y 1 by 2 y square x dx. Thus substituting this, we get 1 by 2 y square log y minus log by y. Thus finally we get log y square, where y greater than 1. So we plot f of y. Yes, so yes, and similarly for f of x, we calculate f of x comma y, differentiation of y, taking y limits from 1 to infinity, and when we solve this, we get 1 by 2x square. Let me see what I did. Yes, integrating y, we get over the range 1 to infinity, thus we get 1 by 2x, and this is not the case, so I guess I did something wrong there. So I again evaluated 1 by y over the interval infinity to 1 by x. I think this is for the range 0 to 1, yes, and this is for the range 1 to infinity, which is separate, yes, and so when we calculate for that, it's 1 by 2x square. Thus we plot f of x 0 to 1 as half, and then it depreciates. In order to prove it's a PDF f of x, we have to calculate minus infinity to infinity. F of x is equal to 1, which is proved, and similarly for f of y is done. Thank you.